All right, so we are going to tackle section 5.4, which is complex fractions. So what I have right here is an example of a complex fraction. All this is an expression that contains one or more fractions within it. That's all a complex fraction is. And so what we are going to learn in this section are two methods for simplifying complex fractions. The first method that we are going to learn is where we're going to take our complex fraction and put it in a format so that we will have a single fraction over another fraction. Oops. Okay. That's what and then once we have that format, then we are able to go ahead and finish simplifying that expression. Okay. So let's go ahead and figure out how do we do this. So step number 1 is going to be to add or subtract, let's focus on the numerator, any fractions that are in the numerator so that we have just one single fraction. And actually, it could be add or subtract the whole expression because there might be an integer there too. And then you do the same thing with the denominator, okay? So our goal, again, is to get a single fraction in the top, a single fraction in the bottom. Then what we are going to do is divide. We're just going to divide the rational expressions that we just found in step 1. And then we simplify. Not so bad. Okay. So let's start with this first example here. That is a complex fraction, and we want to simplify it. So let's just focus first on the numerator. So for our numerator, I have two fractions that have different denominators, x and y. So all we're doing in step 1 is we're creating the same denominator. So I'm going to first multiply that first fraction by y's and the second fraction by x's. So then I have the same common denominator that I bring over, xy, and then I've got my numerator that I just add those terms, 2y plus 3x. I can't simplify them any more than that because they are not like terms. Okay, now let's go to our denominator. 3x minus 2y. Again, my x and my y's are different. I need a common denominator. So again, I want to create xy as my denominator. So I'm going to multiply my first fraction by y, my second fraction by x to create that common denominator. I bring over the xy, I subtract the numerators, 3y minus 2x. Okay? So now I have my, I've actually got this in the format I need, where I have a single fraction, okay, over another single fraction. Yeah, they're a little complicated, but that's what they are. So now I'm going to take my numerator, 2y plus 3x over xy. And then my fraction bar is actually the same as a division sign. That's what we see here. And then I take, and my denominator is what I'm dividing by. So now I'm going to use my keep, change, flip analogy. okay? Or algorithm, I should say. So I'm going to keep that first fraction. So you can see, I just bring it over. I take and I change my division to multiplication. Then the last step is I take my second fraction and I go ahead and I flip it. I take the reciprocal. Keep, change, flip. Once I've done that, I have a multiplication problem. I can reduce. So I reduce an xy with an xy, multiply across. That is my simplified complex fraction. Okay, so let's do this first example here. So I'm just going to focus on my numerator. And I want to have a common denominator of v. And so if I take that integer of 9 and put it over 1, so then I have a fraction and a fraction. My common denominator of v can be achieved if I just multiply that first fraction by v over v. So now I'm just going to go ahead and rewrite this as I've got v in the bottom, and then it's 9v plus 3 in that numerator. Now let's go to the denominator of that complex fraction, v over 4 plus 1/12. So I'm going to go ahead and I need to have 12 as my denominator for both. Well, I can do that. I can multiply by both the top and the bottom of that first fraction by 3's. So then I am left with 3, oops, I want to keep it black. All right, 3v over 12 plus 1/12, which actually, let's just bring those 12s together. So this is 3v plus 1 over 12. So now I have a single fraction over a single fraction. Okay, so I'm just going to take a little bit of a shortcut here, and I am going to, instead of going and changing this first to a division problem and then a multiplication problem, I am going to just take my numerator times the reciprocal of the denominator. It's exactly the same thing. So my numerator times, okay, the reciprocal of the denominator. Okay, so that is going to be 9v plus 3 over v times 12 over 3v plus 1. Okay, so I'm going to go ahead. It's a multiplication problem. I just need to factor and then reduce. So I'm looking at that 9v plus 3. And so I can go ahead and factor that, take out a common factor of 3. So take out a 3, and so I'm left with v plus 1. So actually 3v plus 1. So now my 3v's plus 1 reduce. The 3 and the 12 that are both in the numerator cannot reduce. You can only reduce a numerator with a denominator. So I'm just going to go ahead and multiply across. And so 3 times 12 is 36 over v. That's my answer. All right, let's look at number 2. So the first thing I want to do is I want to create a common denominator in this numerator, okay, in the green part. So I'm going to do that by multiplying that 1 by a over a. So now this is going to become, I bring over my common denominator of a, so that's going to be 1 plus a, because 1 times a is just a. Now let's do the same thing in the bottom, okay, in the yellow shaded part. And so I'm going to multiply that one by the same thing. That's like 1 over 1, so I'm going to do a over a. And so I bring over my common denominator of a, and I take and subtract 1 minus a, okay? So now I'm going to simplify this by changing my fraction bar, my division sign, to multiplication. So I'm going to do keep the 1 plus a over a, change that fraction bar from division to multiplication, and flip or take the reciprocal of that denominator. My a's reduce, and so I'm left with 1 plus a over 1 minus a. That's my answer. Okay, let's go ahead and try 3. So we've got a common denominator of p. Same thing. I'm going to multiply that first fraction by m over m, the second fraction by p over p. So when I multiply across for the top, I bring over mp in the bottom, but then I've got m plus p in the top. Let's do the same thing with the denominator. Multiply by m over m and p over p. And so I am going to end up with an mp on the bottom and an m minus p. Okay, so right here in the middle, let's not lose track of it, my red bar is really a division sign. So I'm going to take my numerator, m plus p over mp. Then that division changes to multiplication. I flip that denominator, mp over m minus p. My mp's reduce, so my final answer is going to be m plus p over m minus p. That's method 1. Okay? All right, method number 2. What we're going to do for method number 2 is we are going to multiply all of our terms by an LCD, okay? All of them. All right, so we've got the example there that you can go through, but I'm just going to go ahead and just kind of dive into this problem. So first thing I want to do is I want to look at my denominators for every one of my terms in that complex fraction. Then, second thing I want to do, I want to identify my LCD. My LCD is going to be x, y. Okay. So now I am going to multiply every term here by x, y. It is very purposeful that I am putting that xy next to the numerator, not the denominator. Here's why. So let me draw my fraction bar. This is where I'm going to put my simplified version. So if I did this right, everything that's highlighted right now is going to go away. The xy and the y and the x. Here's what happens. So in my numerator, the xy and the xy reduce. And so I am left with 25x squared minus 49y squared. Okay? Now, 5 over y, the y's reduce, and I have x times 5, or I can write that as 5x minus. Now I'm going to go ahead and the x's reduce, and so I am left with 7y. My next step is going to be to factor anything that can be factored. And so when I look at that numerator, I automatically notice that this is a difference of 2 squares. And so that's going to give me, in my numerator here, 5x minus 7y times 5x plus 7y. All of that over 5x minus 7y. So my 5x minus 7y's reduce. And so my final answer is 5x plus 7y. There we go. Let's look at problem 5. Same process. We're going to identify the LCD by looking at w squared, w, and w squared. The denominators for underneath that integer of 1 are just 1. And that's not going to change anything with my LCD. So my LCD is w squared. I've got all those w's. I picked the w that has the highest exponent. So now I'm going to multiply all of my terms. I have 5 terms. So it's going to be w squared gets multiplied here, times that 4 over w squared, times that 1 in the bottom, times that 2 over w, and times the 8 over w squared. All right. So now let's look at that numerator. I've got w squared times 1. Well, that's just w squared. And then a minus. Then my w squareds reduce. So I've got a 4. In the denominator, I've got right here, a w squared times 1, which is just w squared. And then, I can't see it anymore, a minus sign. And then our middle term, I've got 2 times w squared over w. So the w in the denominator goes away, and one of those 2 w's goes away. So I just have minus 2w. And then lastly, I've got minus, my w squareds reduce, so minus 8. So my numerator is the difference of 2 squares, so that is w plus 2, w minus 2. Then in the denominator, I want to know what can I multiply that gives me negative 8 but adds to a negative 2. Well, how about w minus 4, w plus 2? All right, so now we can reduce the w plus 2's. And so our final answer would be w minus 2 over w minus 4. All right, so now let's go to 5 and try simplifying this one. So what's kind of unique about this one is that I have this x sitting out there in front of my minus x over 2. It's okay. You don't want to treat it any differently because that x is all part of that numerator. Okay? Everything in yellow has to have a common denominator. And so right now, if I was to rewrite this, it'd be x over 1, and that x minus 3 in the bottom is over 1. I don't want to lose track of that fraction bar. I'm going to put it in red. All right, so my LCD, well, let's be careful here. I only have one denominator. It's x minus 2. That x minus 3 that's in the bottom, okay, let me shade it in green. That actually, yes, it's in the denominator, but its denominator is 1. So the LCD for this problem is only x minus 2. So I'm going to multiply that x sitting all by itself, by x minus 2, my little fraction over there by x minus 2, and this denominator of x minus 3, I'm going to put parentheses around it and multiply it by x minus 2. Funny how that works. And yet, it has to be that way. Okay? All right, here we go. Let's go ahead and simplify this. So, right here in the upper left, I have x minus 2 times x. Let's just go ahead and write that like that. X times x minus 2, just so you can see it. And then the x minus 2's reduce, so I get a minus x, okay? In the denominator, I have x minus 3 times x minus 2. Okay, we got a lot going on there. Let's go ahead and do the easy stuff first. So I can distribute this x. So I've got x squared minus 2x and then minus x. In the denominator, I'm going to just FOIL that denominator or just multiply it. And so I'm going to get x squared minus 5x plus 6. Okay. I can simplify this numerator a little bit. And so that is going to be right here. If I bring together my like terms, that is going to be x squared minus 3x. And that is all over, let's leave it this x squared minus 5x plus 6 for a moment. All right, now this numerator, I can take out a common factor of x, so I've got an x times x minus 3. Maybe I got a little multiplication happy way back here. Okay, way back here. If I had left that as two separate factors, which I should have known better, that's a lot of times what happens. I should have just left it. The x minus 3 times the x minus 2. Watch this. The x minus 3's reduce. And so our final answer is x over x minus 2. All right. Let's go ahead and do number 6. Actually, I want it for time reasons. I'm going to skip 6 and go on to 7. 7 actually looks different because we have negative exponents in there. And I want you to understand what that means. So you've got this b to the negative 1 and a to the negative 1. What does that mean? Okay, so remember, it means that b to the negative 1 is in the wrong place. How do I deal with that? Here's how you deal with it. Let's write our fraction bar. When I say wrong place, it doesn't mean to put it in the denominator under that black line. What it means is to take that a, b to the negative 1 and create a fraction, which is a over b. That's what it means. Minus 2. Now we're going to do the same thing here with that second term in the denominator. So that's going to be 1 minus, the a goes in the denominator. We're going to create a fraction, and 2b stays on top, and the a goes in the bottom. That's how you deal with the negatives. Okay, so now let's go ahead and I want to look at the b and the a. Those are my two denominators. So I want an LCD. My LCD is going to be AB. So I'm going to multiply all 4 terms by AB. AB times A over B, 2 times AB, AB times 1, and then 2B over A times AB. There we go. Now, let's go ahead. I want to leave room here. Let's put our fraction bar. So let's start in this upper left corner and simplify. So the b's reduce. And so I'm simply left with a squared. Now, and then I've got minus 2ab. Okay, we can see that. Now let's move down to the denominator. So this is just AB times 1, which is just AB. And then we've got right here this 2B over A times AB. So the A's reduce, and so we have minus 2B squared. Okay, so now fraction bar, let's focus on our numerator. I have a greatest common factor in the numerator. I can pull out an A. So I pull out an A, and there's an A minus 2B. Now for the denominator, I'm going to pull out a B. And I'm left with A minus 2B. So my A minus 2B's reduce, and so I am left with A over B. Well, that was fun. That was good. All right. So you should have what you need here in order to successfully complete the homework.